71. All right. So exponential growth and decay, not brand new to you, but I feel like we do need to review it. And then after second period, when literally every single person I asked, so what is this? And I had people help me. No, there were people that didn't agree with every single person. So clearly there's some parts here that we need to review. Some of it was typing it in the calculator. Some of it was understanding the words, but just making sure we can all fully get this correct. So we've got these exponential growth and decay functions. The exponential growth function looks like this. F of t is equal to a times 1 plus r to the t power. Decay is going to be f of t equals a times 1 plus r. No, it's not, because that's decay. Sorry, I'm just rewriting the same thing there. 1 minus r to the t power. And r being the rate. So I want you to think about if I am going to go and buy something for $25 and I have to figure out how much it's going to be with tax, right? When you first started doing like tax problems way back whenever you did, probably the way that you were first taught was you take the $25 and you're going to multiply by the tax rate, which is 0.0825, and you figure out this is however much the tax is, right? And then we take that and we add it to the $25 and that's our total, right? And that works. There's absolutely nothing wrong with that. But can I find my total with tax all in one step without finding and then adding? What do I do? 1.082, not 1.825, that'd be way too much, but 1.0825, right? Because you're taking the 100%, basically it's like this. It's 100% plus the tax rate, right? And if this is my $25 out here, t would be 1, because we're not going to, exponentially grow our tax or anything. But this is 1 plus the 0.0825, and this was $25 out here. If I distributed that, it would be 25 times 1, that's $25, plus $25 times whatever the tax rate is, right? And that gives you your tax. So if you just go ahead and add those two things together, that 1 is always that 100% that happens in there. Does that make sense to you? So that's your 100%, that's your rate. So when you combine them together and get one number in here, this really looks just like the exponentials that we've been doing anyway, right? These are just split, but it's just putting everything all in one spot. Plus, if I'm looking at, so let's say I buy it, and I buy it for $25, and I pay the tax, and then I'm going to sell it to you, but I'm going to charge you a fee that's the same as the tax, right? So then that would have to be, added on to that, and maybe I'm going to make you do 100% plus that 8%. That's where your 2 would come from. That'd be really mean because it would be really expensive. But you have to do it again. But if you just keep going and keep going and keep adding it, that's what's happening with the exponential growth that's there. Okay, so again, I know these aren't new to you. You've probably seen them multiple times throughout the years, but that's what's happening with them. So we've got to make sure we can take these and apply them when we need to apply them, and we can write them down correctly. And we can answer the questions correctly, because just because a calculator is put in your hand doesn't mean you just type everything in on the calculator. All you can put down here is answers. That's a big fat no. That will get you a big fat 0 on the AP exam, because you still have to show your process, your thought process, not just a bunch of random numbers, because I'd punch this and then this and then this. That doesn't mean anything. Doesn't mean you understand the concept. So on number 1, it says, Brooke started her career with an annual salary of $32,000. Each year thereafter, her salary increased by 2.5%. Write and use an exponential growth function to find her salary when she retires after 3 years. Write a function first. So f of t equals, what would the a be in this case? 32,000 times 1, because it's increased, 1 plus what? 0.025. 0.025, and then that's to the t power. That is my function that has to be written, okay? So I don't know what you're doing, but you're not doing what we're doing. You put that away. We're using that one right now, and you should be writing this down. Okay. So then f of, what's my t? 30, okay? And pay attention to these types of things. This is each year, blah, 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 is this percent. And then find her salary and she retires after 30 years. Sometimes those things don't match, and you have to think a little harder on that. So this is f of 30 equals 32,000 times 1.025 to the 30th power. Both of those equations have to be written down for you to get credit. Then you can type that into your calculator. So go ahead and type that into your calculator. Oh, I'm sorry. I just realized your attendance sheet wasn't up there. Everybody screwed over. All right, so then my answer isn't just a number. My answer isn't f of 30 equals. I have to answer the question in a sentence. So I can say Brooke's salary when she retires after 30 years is... Sean, what did you get? Okay. All right, so do y'all agree with that? Yeah, actually this one everybody did agree last period, now that I think about it. Now we got to think about rounding, okay? Because the AP rules are, unless it says otherwise, you should round to 3 decimal places, blah, blah, blah. But this is money, so does it make sense to go to 2 decimal places? Yes, it absolutely does. So you have to use some logic with your rounding here, okay? When, you know, when I do decimals and geometry, I take decimals completely away, and then when I give them back, everything is to 3 decimal places. I don't care if it's money, I don't care what it is, because nobody can make the right decisions at that point. You have to be retrained. But you've been retrained, and you should be able to now make logical decisions on what should be rounded correctly. Does that make sense to you? So think about what makes sense in each situation there. All right, so hopefully we got that down, no problem. All right, so go ahead and write both of the equations for number 2. And you can go ahead and write them and find the numbers. Okay. George, tell me, this is going to be f of what? 21? Do y'all agree with 21? Everybody? Yes? Okay. I had quite a few people last period that wanted to use 11. Okay. But we understand where 21 came from, right? And when you find 21, let's just talk again about logic here. Are you going to literally take 2016 and subtract 1995 and then carry and borrow and all that stuff? Hopefully not. I mean, you get 16 years to get you back to 2000, and then you got 5 more to go back, so it's really just 16. Start being able to think through processes like that, so it's to the 21st. All right, so then I can say, now if you've already written your sentence doesn't have to be word for mine. I mean, you can word these in different ways and say the same thing, but what I'm going to say is, the magazine will have blank subscribers in 2016. All right, so let's see. Twan, what did you get? What would that number be, Twan? Can you be a little bit more specific? Okay. You know what helped me? Because it's a big number to look at in the calculator, right? Write the number down, then put in your commas, and then it'll be easier for you to tell me what it is. Oh, yeah, sure. No, I didn't ask you. I asked Twan, whoever was talking. So write it down. Okay. Okay. Y'all agree with that? Is that what you said? Yeah. Okay. Do y'all agree with that? Yes. Now, is that exactly what the calculator gave you? No. But can you have part of a person? No. So again, that's where your logic comes in with the rounding. Yes? Awesome. Good job. All right. So let's write down the next two equations. Thank you, Twan. All right, Jacqueline, can you give me your first equation? Okay. Do y'all agree with that? Yes? Does everybody have minus there? Why is it minus, Jacqueline? Good. It's decreasing, and it's a decay function. So you have to have that minus there. Okay, good. And then what is your t going to be, Jacqueline? 8. Good. So f of 8 equals 150. Now, when you get to this point here, are you like, oh my God, I have to subtract decimals. This is like the worst day ever, even though I have a calculator? You don't even need the calculator. Isn't that just like 100 minus 12? Yes. Which is 88, so 0.88 the 8th power. Okay, so then our sentence would say, Kate will have blank of caffeine in her system after 8 hours. Okay, so Reagan, what did you get? 5.3945. Do y'all agree with that? Yes? Wait. Okay, and you got here. Let me see what you typed in, because that's the number that I got last period too. Oh, look, you put in 15. What happened to your 0? She's making stuff up. That's okay. I make stuff up all the time, and it never works. So she will have. So what did you get this time, Reagan? 53.945. Yeah. And it's 945 there, and it's milligrams. So make sure you label that. 3 decimal places. The AP rules are 3 decimal places, unless you're told otherwise, or you have other logical reasons. But I know AP Stats is different, but it's different. It's just a whole different everything anyway. So it's 4 in there for those purposes, but it's 3 for everything else. Correct to 3 decimal places. So make it correctly as well. That's an important skill for you to have. All right. So then number 4. Go ahead. I just want you to write your first equation and stop. First equation and stop. Okay, what is your rate here? What is it? 1/2 y. Because it's half-life, right? So you gotta know what half-life is. So half-life tells us that our rate is equal to 0.5, right? Does that 197 play a role in my formula or my equation? No, it does not. All right, and then in 3 days, we're going to an exponential decay function. That's important there. So it's going to be f of t equals, it's a 50-gram sample, so 50 times 1 minus 0.5. There's other things that you have to pay attention to. If you look at the other problems that we've done, on number 1, it said each year her salary increases by 2.5%. What's her salary after 30 years? So it was years and years, right? Well, half-life, this 0.5 only happens every 3 days. And I want to know what's happening after 20 days. So is this just t to the t power up here? No. So is it 3t or is it t over 3? T over 3. Okay, so this is over times this t to the t divided by 3 power. Does that make sense to you? Why it's that? You got to read what's in there. All right, so then we do f of 20 days. That's equal to 50 times 1 minus 0.5 times, or I'm sorry, not times, but to the 20 over 3. You can do that all in one step in this calculator if you used your parentheses correctly. So make that happen. So I'm going to show you one nice thing about this calculator, because I should be like a spokesperson. And then so on this one, I'm typing it in, and I can do that 50 times 0.5 to the, and then I do my little exponent here. You see how it puts all in that little exponent right there? And then I can put a fraction in my exponent and do 20 over 3. You see how you see it all? It looks a little bit nicer than what you have, because those have these little caret tops. So then after the caret top, you got to put in parentheses 20 divided by 3, and it's spacing them out like the 83. The 84s that have been updated do nice things like this in the exponents as well. Most of those graphing calculators that we have, but anyway, so that is the answer that you should have come up with on yours. Yes, okay. Which again, sometimes these things get really long and you can't even see what you're typing in. That just kind of becomes it. All right, so then my answer to that is 0.492 grams. So there will be 0.492 grams of mercury-197 left after 20 days. Yes? Good. All right. So now let's talk about continuous growth and decay, which I still don't have the time to show you that 2-minute video. I may just end up sending the link in a remind. It's early 2 minutes long. So you kind of get the idea of what's happening with E. Now, the continuous growth, we still take little snapshots at certain times. It's kind of like you're continually growing, right? You're not necessarily in an exponential type of way, but you're continually growing. Your cells are changing, and, when you sleep, your brain grows and your body grows. You have like physicals every year. So the doctor goes, oh, you grew 2 inches this year. Well, did you grow 2 inches in the waiting room right before you saw the doctor? No, you were continuing. I tried really hard. You were continually growing over that year, but then you have that snapshot once a year, right? I grew 2 inches this year, grew 1 inch that year, but it's not like it's instantaneously, right? Whereas when we're doing like interest, I'm going to calculate it right now. Do my tax, I'm going to calculate it right now. Boom, 8.25% got added right that second. Not what's happening with continuous growth and decay, and that's where that E comes into play. And that little video shows a pretty good basic way of showing how you can get to that and what's happening in the different ways. But so it says sometimes a quantity is constantly increasing or decreasing at an exponential rate, and not just after each year, month, day, hour, etc. The formula to the right can be used to find the balance of the account, but it's not always an account. Okay, and it's A equals here, and then anybody tell me what this is? It makes a little word here. Almost close. P times E to the R. So it's PERT. It's your PERT formula. You have the PRT in there, but you need the E. So R is positive for growth and negative for decay. So let's look at this. A garbage dumpster started with 4 pounds of garbage. The amount of garbage increased continuously. Anytime you see the word continuously, that's like, oh, E. Just like when you see ratio, you go, oh, that's a fraction, right? By 35% each day. That doesn't mean somebody dumps trash in once a day and it's 35% more, but it's continuously by 35% each day from this point forward. Find the amount of garbage in the dumpster after 2 weeks. You may have mostly used this formula for account balances and stuff. It's a gross account to have, so this is definitely not an account balance type of thing. But we have A equals, what's your P here? 4. Times E to the rate is 0.35 times t, which is what? Is it 2? It's 14, because each day and then 2 weeks, so this has to be 14. Oh, wait, that should be t first. I'm sorry. Let's back up. I didn't write the formula. 0.35t. You got to have the original one, sorry. And then it is each day and then 2 weeks. So then your next one will be a equals 4 times e to the 0.35 times 14. All right, so there will be garbage in the dumpster after 2 weeks. Okay. Everybody okay with that? All right, now type all that in. And then Melanie, tell me what you get. Oh. It's right, it's above the natural log. Yeah. So did everybody find that? Where the e is? E goes with natural log, and so it's the second part, which you really can't even see on my document here, but it's above the natural log. All right, so what'd you get? 79.167. Y'all agree with that? Okay, so this is a common thing. I'm going to use this if you don't mind, because I know you're not the only one that does this. This is the exact same thing that happened last period. So she typed all this stuff in. Oh, and again, I know that she's not the only one. I did this. So she typed all this stuff in, but on these calculators, which may be like a calculator, do you want to make sure you know about what you're telling the calculator to do is take 4 times e on it, that times 4 inside of those parentheses. This, sweetheart, it's all good. I'm not trying to call you out. On this one, it puts the exponent up there for you like the 84s do and some other calculators that are scientific like you might have, but 4 times e, and then it puts it up there. When I do 0.35 times 14, it all stays up there and I can see that that's what's happening, and then it'll give me that answer. Where this, if it was any longer than this, you can't really see what's there anyway unless you scroll, which can be frustrating. So just make sure your parentheses are in the right place. Okay, I had multiple people do that last period. Don't feel bad. I'm not trying to make you feel bad. Just we need to make sure that it was $12. Yes, it might be cheaper at Walmart. I need to look and see if they have it at Walmart. I got it on Amazon for $8. That thing was $12. It's going to get even better when we get down here. You just wait. I'm going to wow you with my $12 calculator. All right, so there will be 537.159 pounds excuse me, of garbage in the dumpster after 2 weeks. So that one having 3 decimal places makes sense. I mean, the garbage man might only care that there's 537, but you know, we need to make sure that we're good with our numbers. All right, so go ahead and write down make the equations for the next one. And there's really nothing like magically special about that specific calculator. I'm sure there's other models which might be about the same amount that do some most of the same things. I just looked for the one that was the cheapest with the best reviews on Amazon. And that's what I came up with at the time. And so you may already have one that does the exact same things. Sometimes those are the kind of calculators that might be laying around your house that you don't even know is there, that somebody has shoved in the back of the drawer somewhere. So just ask about scientific calculator and get fancy. All right. Let's see. All right, Ernest, can you give me the first formula here? Okay. Y'all agree with that? Yes? Okay. So then what would your next formula look like? You don't agree. They don't agree anymore. Why is it negative? Declining at a continuous rate. So what was going to happen? So then in the end, what was your final answer? Or did you get that yet? Yeah. Is it like a ginormous number? Oh, look what you did. Oh, dang it. Okay, well, let me ask you, that number that just disappeared because I made you hit a button, was it more than 16,000? So would you have caught yourself in the end? Maybe? Yes. Okay. And that's all that really matters, is that you catch yourself and you're like, wait, something's not right. So do you understand why it's negative then? Everybody good? Yes. All right. And then we're going to change t to 8. That's pretty obvious. It gives me that. So a is equal to 16,000 times e to the negative 0.015 t, times 8. Duh. So then our answer would be the population after 8 years will be, all right, so what did you type in and what did you get, Ernest? Ernest. Okay. What, 190 what? 190. So 14,190 people, right? Because technically it rounds up to 191, but can you have part of a person? No. Think of like the bus. The bus holds 48 people. You got 48.6 people. Well, guess what? Sorry, only 48, right? You don't get to round up to 49. So 49 people aren't going to fit. So what? 14,190, which is less than 16,000, which is what we would expect. We good with that? Okay. So now, none of that really should be brand new to you. Logistic growth, I don't think is anything that you have seen before. Logistic growth is something that you get into if you're going into Calculus BC. Now, I want to make sure everybody understands, when we talk about Calculus AB, that's equivalent to Calculus 1 in college. Calculus BC is equivalent to Cal 1 and Cal 2 in college. So even if you're thinking, I'm not taking BC, well, you may end up in Cal 2 in college. Maybe you're not taking calculus at all in high school. But if you ever take Calculus 1 or Calculus 2, then that's basically A, B, and BC that I talk about. So anyway, this is something that comes up in BC, which means it comes up in Cal 2. And so it says sometimes a quantity exponentially increases, but then levels out approaching a horizontal asymptote. This is called logistic growth model. So there are things like we have a horizontal asymptote in all of our exponentials, but there are times where it's not going to continuously increase to infinity. It's going to have to level out at some point. And this is, you know, a lot of the business models and whatnot, because you can only expand so much. If you look at, and so it gives you the equation here. So if you look at this question here, it says a disease begins to spread in a town of 20,000 people. After T days, the number of people that have been infected by this disease is modeled by the function below. Using the function, find the number of people. All right, so the number of people infected is going to increase, but it can't increase in exponentially to infinity because it can't surpass the number of people in the town. Does that make sense to you? That's why it has to level out. 20,000 is as high as it could possibly go. So that's where your logistic growth function comes in. The good news about this is that it's so new and we don't have some of the other skills that we need for it. Basically, they just gave it to us. So you could have done this forever ago because you just have to substitute in a number and be done with it. Understanding the concept of what's happening here and that it's still exponential is important. So it gives us all this stuff, blah, blah, blah. It says using the function, find people infected after 10 days. So what is T? 10. But be careful because this does say 10 days and then this says after T days. Sometimes those two words don't match. You have to fix things. But so f of 10 is equal to 20,000 over 1 plus 1150 times e to the negative 0.95 times 8. No, times 10. Where the heck is it? So type that in. You can type that in all in one step on your calculator if you use the parentheses correctly. So try that, or maybe do it in one step, but I want to make sure you understand how to use these calculators to be able to do this, even if you have a different one that you can use at home or when you're outside of class. Because again, a lot of times the way these work, which is not in a nice way, sometimes is also what's going to work on your phone, unless you have paid for another calculator or something. Who wants to give me what they got? And I'll tell you if you're right. Anybody? What did you get, Serge? Good. 18,414. Can I see what you typed in? Okay. Agree with that? Yes? Okay. So let's look at how he typed this in, which is not the only way that you can type this in, but we have this, right? And so he's just divided the open 11 to the e power times negative 9.5. Okay, so it means before that you multiply those two numbers together, which is fine, right? You multiply 10 times the negative 0.5, which you can have to. I mean, that one's pretty easy to do in your head, but you could do in here the two multiplications in those parentheses, and when you hit enter, you're done with all that. Now, that's a lot to type in where you can't see it on this specific calculator. So let me show you another way that you can handle it, because sometimes it's easier just to take care of stuff in the denominator and do things in pieces if you know how to do it correctly. So nothing wrong with all the parentheses. Some people, the parentheses stress them out and they can't get them in the right places. So if I take care of just the bottom part of the bottom part of the fraction with that 1150, and I do 1150 to the e power, not to the e power, that doesn't make any sense. 1150, sorry, times e to the negative 0.95 times 10 power. So I get this, not my answer, right? And I know it's not my answer. To that, I'm going to add the 1, and that gives me my whole denominator. Okay, everybody with me on that? Now, I don't want to multiply that by the 20,000. I want 20,000 divided by that, and I don't want to have to do anything. So multiplying by the reciprocal, the same as dividing. So how can I get the reciprocal of that number? 1 over this, but I don't want to type this negative 1. But sometimes that's less. To the negative 1 power. So if I just take that answer, that gives me reciprocal, right? And then, oops, did it? Damn. And then if I multiply that by 20,000, I got it. Right? Yes, there's multiple ways to do this, but now I want to show you where I'm really going to wow you, and you're going to want to go buy one of these today, just like me. All right, so we're going to do this 20,000, and I'm going to put it in a fraction. Bam. And in my denominator, I'm going to put 1 plus 1150 times e to the negative 0.95 times 10 power. And it's all there, all in one fraction. See how much nicer that is to look at? Make sure that I have everything in the right place. Because even if you know where the parentheses go, sometimes you hit the wrong number, or you can't even tell if you did it right. It's all right there beautifully. It gives me the answer, and it still shows it to me. And I'm not as stressed out. Yes, you absolutely can. This is, you can use the things that you can use on the SAT. They can't have a, they can't factor for you, and they can't have like a solver on them. Like, well, actually, no, they can. They can't have a, it's a CAS, is something, I forget what it says, and it can't have a QWERTY keyboard. But yeah, this right here is, because I don't have did you need the graphing part of the calculator for the SAT? I don't think you need it at all. To me, something like this would be way more beneficial to you. And yes, you absolutely can use this on the SAT. Because you can use the Inspire too, which do so much, but if you don't already understand them, it takes a while to get the hang of what's really going on with them. They're a little funky. So, and those are kind of coming up through there. I start looking a little bit at them if that's something that Mr. Allen is going to start trying to use. And he did for a while, and then he went away from them, and then we're kind of forced to buy some, and then so we're kind of using them, even though none of us really love them. All right, so with all that said, make sure you can type things in right. Then I need to say, find the number of people infected. Okay, so we can say that there will be 18,414 people will be infected after 10 days. All right. So go ahead and work on number 8 while I pass out the homework. So would some of y'all be interested in this specifically, what that calculator is? Let me tell you that. To ask Santa. So I'll send you the Amazon link through Remind, and then I'll look and see if maybe they have it at Walmart too. You might be able to go buy it, but I buy everything I possibly can off of Amazon. But if you're not already a Prime member, sometimes it's not worth it. Prime is the best. Oh my gosh. I don't know how I survived before. I had to actually go to the store and stuff. And I mean, I encourage you to shop around too. There might be one that's even better than that, but I don't know if it would be better for $12. So. All right. Pearl, tell me what you got. Oh, I'm sorry. Okay. So I'm still going to have her tell me the number, so I don't want you to tell me the number, but any of the rest of you type it in and be like, that can't be right. Make you type it in again. What'd you get? Okay, so does that seem like a weird number? Yeah, at first, like, for a population of a country, you're like, so is that wrong? Why is it not wrong? Because it's in millions. The population peak in millions. So that's not wrong. It should make you kind of go, whoop, what? And then if you think about what it means, it's not wrong. So it's 12.185. No, 12. What was it? I'm sorry. Oh, 185. I didn't put the 1. 185 and then million. But that million is an important qualifier there, right? It's not just 12.185 people. And you don't have to write it out with a bunch of numbers and make it in the millions. You talk about it like that, and it's all fine and good. Okay? We good? Any questions at all? All right, so here's the thing. If you're doing this on your phone or a calculator where you might have to type some things backwards and it's not as user-friendly, use some of the problems we did up here and just retype them in. You get the same numbers. That way you know you're typing it in correctly, because that's an important thing too.